Hi everyone, in this video tutorial I'm going to go through the Newton-Raphson iteration process of finding the roots of the equation fx equals 0. So I've just entered this equation where fx equals x cubed take away 3x plus 1. We can see it's got three roots, none of them are integers, and it's one of them between minus 2 and minus 1, the one's between 0 and 1, and the other one lies between 1 and 2. I've also just taken a point A and I've put it on the x-axis, and this allows me to select an input value. Now what I'm going to do is use the spreadsheet to do my calculations. So over here I'm going to choose, let's say, the x coordinate of point A, and I'm just going to double check to make sure my rounding is to 5 decimal places, which it is. And let's just put this back over to the corner. There you go. Right. And so this allows me to check my input value. Now we're going to feed this in to the Newton-Raphson iterative formula, and we know the x n plus 1 term is given by xn, so in that case it's a1 take away f of a1 divided by f prime a1. So let's do that. And the good thing about Geogebra is, since we've defined fx, it automatically knows we can work out what f prime x is. So let's press enter. We have some values, and let's scroll this and bring this all the way down. Okay, so we can see that it converges after 4 iterations to a root, and then repeats. And if we were to take the starting point to be, say, 0, it converges again to this root between 0 and 1, and then if we take it to minus 2, again it converges. So we can use this process to find all three roots. Now let's illustrate this and illustrate the process that's going on. So let me just zoom in a bit and maybe just move this about over here. Now the first we want is a line that goes from our x0, which is given by here, that represents x0, and goes up to this point on fx. So we'll say, let's choose a segment function. We need to define 2 points, a starting point and an end point. So our starting point is going to be when x equals a1 and y equals to 0, and then our end point is going to be where x is still a1 but y is f of a1. Let's put that there. There we have it. Now I can see there's obviously a label, so I'm going to take away the label and then just copy all the way down. So let's go to about 30, and obviously I can notice there's other labels there, but in fact if we were to zoom in and out, they disappear. Let's just test to see if this works. Indeed it does, so we get some straight lines. Now we want a line that joins, let's have a look. Now since this is x0 and this point here is x2, our input has gone to fx, and then it comes back to give us x2. So we need a line that joins this point of intersection to this point here. So let's use another, let's use a segment function again, and so we've got this point, and we've got x is a1 and y is f of a1, and let's put a bracket around that, and then we've got a comma. It's very important to be careful of brackets. Very easy to make a small mistake and then you won't see a line. Now the next point is our x2, which is given by our cell a2. So let's do that. So we've got a2, and then it's obviously where n x equals to 0, and close the bracket, and there we have it. Now again, let's get rid of the label, and let's just send this, oh here we go, and let's bring this all the way down. Okay, now go to zoom out, there you have it. Now it's probably good to color code this, so let's Let's do object properties, and let's change the color to blue. Okay, so there's our FX. Whoops, doesn't seem to have taken effect. There we go, there's blue. And we can move this around. Now let's also change this label here. Let's rename this to X0, which it is. I didn't label it earlier because obviously I was going to use it in the spreadsheet, and then I would have had to enter X0, which is a bit of a faff. But obviously entering XA is probably easier. So here we obviously move this around. This point here, I'm going to label this is X0. Now one of the ways we can label it is just look at intersection, and it's obviously the intersection of this line with the x-axis, and that gives me a point. We can, whoops, not that. We can rename this point as X1, okay, and so forth. Okay, so there we have it. Now let's see what, so there's the iterative process. We can obviously widen our view by widening the axis over here. Now one of the things to note is that we actually have a tangent. These lines are in fact tangents, and whether you want to color code this and annotate it is up to you. But one way we can illustrate this is to look at the point of intersection, say with this line and this line. That gives us a point. We can, and then we can look at the tangent of this point with our fx, and let's just turn that into a dotted line, which is red because it's not part. There you go. It's not part of the actual thing that we did, and so you can see that what comes down is always the tangent. And as we change this point, obviously it's always going to be the tangent. Now to demonstrate failure, we need to look at an example where the gradient near under an integer at a station point is 0, and so therefore the equation, when we work out f prime x at that point, it fails to calculate. So in this case, if we were to take a point, say we're looking for this root, say we're to take this point when x equals 1, we can straight away see that our iterative formula collapses and it no longer works.